Hello everyone, in this video we'll discuss about linked list implementation of queue. The array implementation cannot be used for the large scale application where the queues are implemented. One of the alternative of array implementation is linked list implementation of queue. The storage requirement of linked representation of a queue with n element is big O of n. While the time requirement for operations is big O of 1. In a linked queue, each node of a queue consists of two parts. That is data part and link part. Each element of a queue points to its immediate next element in the memory. In the link queue, there are two pointers maintained in the memory. That is front pointer and rear pointer. The front pointer contains the address of the starting element of the queue, while the rear pointer contains the address of the last element of the queue. In link queue, every element having two parts. One part store the data and another store the address of the next element. And the start pointer of linked list is used as a front. And the rear pointer will store the address of the last element in the queue. All the insertion will be done at the rear end of the queue and all the deletion will be done at the front end of the queue. If front is equal to rear is equal to null, it indicates that queue is empty. There is no element in the queue. Next is the algorithm to insert an element in a linked queue. Link queue insert is the name of the algorithm. Info is the information part of the node and link is the address part of the node. And the front pointer contains the address of the starting element of the queue. Rear pointer contains the address of the last element of the queue. Avail is a pointer for free storage space. And item is the element that we have to insert into a linked queue. This is a linked queue having 3 nodes and this is the available space. In a free pool, first step of algorithm is to check the available space. If avail is equal to null, that means available space is not there. Then write overflow and exit. Otherwise, remove first node from the avail list. Set new is equal to avail. Avail is 5 and avail is equal to link of avail. Avail points to the second node in the avail list. And third step is set info of new is equal to item. Info of 5 is equal to item. Item is the element that we have to insert into a linked list. Item is D. And set link of new is equal to null. Link of 5 is equal to null. If front is equal to null, that means queue is empty. Then set front is equal to rear is equal to new. Now in this case, this condition is evaluated to be false. Queue is not empty. Then else if link of rear is equal to new. In this queue, rear is 3. Link of 3 is equal to 5. Now rear points to the new node appended to the end of the list. This is a complete algorithm to insert an element into a linked queue. Next algorithm to delete an element from a linked queue. Linked queue delete is the name of the algorithm. Info is the information part of a node, and link is the address pointer field of a node. The front pointer contains the address of the starting element of the queue. The rear pointer contains the address of the last element of the queue. Avail is the free storage space in a free pool. Item is the element that we have to remove from a queue. Now in this case, item is A. We have to remove first node from a linked queue. First step of algorithm is if front is equal to null, then write underflow and exit. Front is equal to null means there is no node in a linked queue. Then write underflow and exit. Otherwise, set temp is equal to front. Front is 1. And third step of algorithm is item is equal to info of temp. Item is equal to info of temp. Info of 1 is A. Then fourth step is front is equal to link of temp. Reset front to point to the next element in the queue. Now front become 2. And link of temp is equal to avail. Link of temp points to the avail. Now avail is equal to 1. Avail become 1. That means return the deleted node temp to the avail list. This is a complete algorithm to delete an element from a linked queue.